My name is Sandeep Sovani. I have the responsibility for looking after automotive industry marketing and business strategy on a worldwide basis at Ansys. In Ansys, we think of business units as verticals and horizontals. So from a product perspective, we have a number of horizontals, horizontal business units. We have a business units for fluid simulation. We have a business unit for mechanical simulation, for electromagnetic simulation, and for system simulation. Also another one for software simulation, because software is becoming quite important now. And then we have verticals, industries. So Ansys serves many of the major engineering industries. To name just a few of the major ones, we serve the automotive industry, aerospace industry, defense industry, high-tech industry, healthcare industry, oil and gas, other natural renewable energy production. So there are a number of industry sectors that we serve. So from an Ansys classification perspective, when I say automotive, we really mean the entire ground transportation industry. So anything that has wheels and moves on the ground is part of the automotive industry, and in newer things that don't have wheels but still move on the ground, like the Hyperloop, are still part of the automotive industry at Ansys. So all ground transportation in that sense. It includes agricultural equipment, it includes trucks, it includes motorsports, two-wheelers, railways, apart from traditional cars and trucks. Ansys strategy is focused on 4 core fundamentals. First one is advanced technologies, which is having the best raw capabilities in the solvers for fluid dynamics, for structural mechanics, electromagnetics, etc. We have over the years done a lot of investment in making sure that we have the best technologies when it comes to solvers and the core technology. So that's one pillar of our strength. The second pillar of our strength is being able to put all of these technologies together to test a complete virtual prototype. So you take a vehicle system like a brake, we can study it not only from the fluid side, but the thermal side, from electromagnetic side, etc. That is our second pillar of strength. The third pillar of our strength is process compression, where simulation, we are continuously putting technologies that can compress the process of doing simulation. So companies can do more simulations and derive more benefit from simulation. So things like having wizards or special programmable capabilities that allow people to create custom workflows and then speed up their simulation. Or high performance computing. We are big time in high performance computing that compresses the process of simulation. And the last one is about dynamic collaboration. So companies, and we saw it in our keynotes here today at the conference, companies have very diverse workforces today, spread all around the world, and it's becoming a much bigger challenge for them to collaborate with each other and do meaningful work. So we keep a conscious mind in developing our products to make sure that the products have features that allow people to collaborate easily. There are a few different trends. We can classify the trends in few different ways. The basic trend related to basic simulation, like basic structural simulation or basic flow simulation. The one trend that's continuously been going on in the market is more awareness and acceptance of simulation. So even 20-30 years after simulation was introduced to this industry, not all companies do simulation today. So more awareness is continuously building, and more acceptance of simulation as a tool is building. We saw in this conference some keynotes talking about some of the parts of vehicles are now completely virtually qualified, and the supplier can just give a virtual verification to an OEM and they don't ask for a physical prototype test. So that level of acceptance is growing. So that's a kind of a groundswell trend for growth of automotive simulation. On top of that, there are mega trends that the entire world and economy is seeing, and that is, it so happens now that the automotive industry today is at the center of some of these big trends that are causing paradigm changes in the world. IoT, for example, and autonomous driving are big changes. If you think of autonomous driving, think of the scenarios of what an autonomous vehicle needs to be designed for. Car driving in the rain, suddenly some animal crosses the road while there is a nail which is making the tire go flat. Combinations of such things do happen in the real world, and there are literally billions of combinations of this. So by some estimates, for creating an autonomous vehicle and testing it to the level that vehicles are tested today would require an autonomous vehicle to be tested for billions of miles, and it will take 100 years of testing for one vehicle model to be released. So testing is virtually impossible to do, and therefore simulation has a much bigger role than ever to play in bringing autonomous vehicles to life. That's one of the big trends going on. The other trend is more electrification of vehicles. This is something that started about 7-8 years ago with the electric powertrain, and it spurred a lot of simulation 7-8 years ago, which is now kind of mainstream in the automotive world. Cars have been electrified from another sense. There are a lot more electronics in the cars these days, and typically electronics in the high-tech industry are designed for a much shorter life cycle than the life cycle that is they are required to deliver in a car. So a cell phone delivers a 2-year life cycle, but a touchscreen on a car has to give a 15-year life cycle, and that has tremendous implications in making sure that the electronics are reliable, thermal reliability, structural reliability, etc., which requires an immense amount of simulation. If you think of the automotive simulation software market, that is about today $1 billion market, which is car companies and suppliers around the world every year spend $1 billion in licenses of software. That's a conservative estimate. It's possibly bigger than that if we count codes that are in-house and things like that. And this space has a lot of companies operating in it. There are a few dominant companies in certain areas, but there are actually dozens of companies operating in this space. So any company as such has a small pie. There isn't a company that has a dominant market share like 50% or plus. Ansys is the top company in this space with market share of about 12% or so in this space. But that gives you an idea that even the biggest company has a relatively small market share. So there are different companies. If you look at it from another angle, if you look at a typical OEM, a company, car maker company, they maintain a portfolio of literally hundreds of different software tools for doing their computer-aided engineering. And that gives you an idea of how fragmented this space is in terms of tools. And again, every company offers at least 10 tools, different tools for doing different things. There are again niche tools doing niche things. So this space is unique characteristic of this space is that there tend to be niche tools that have strengths in certain things, like companies that would have strength in doing the software embedded software development or embedded software modeling. Another company might have strength, they have their entire business focused on doing aerodynamics. Or another company, there are some companies that have an entire focus on simply creating mesh models for vehicles. So we tend to see that the industry is very segmented that way with niche players. Ansys takes an approach of being a general purpose provider, and we compete with a lot of niche players, but in many of the niches we provide a strong solution that can compete with the niche provider, even if the niche provider is focused on only that particular area. Because the space is so crowded and so vast, and car companies or suppliers, they essentially want to use the best tool for the purpose, and the best tools could come from different vendors. So the reality of the space is that there are always going to be dozens, if not hundreds of tools in play. So for any company like Ansys, we have to have an open strategy of collaborating with other companies. We have, for example, 90 or more software partners that we actually partner with, where we create connections between their software and our software, so the software can run together well like the customers want to run it. Or we also provide open APIs where other companies can link to our software on their own, or we could link to some other company's software in our software on their own. Or even we provide customization where a customer can take the software and customize it as they want into their workflow with some other software. Ansys has always been quite forward-looking in terms of the investments that we make for the automotive industry. So we were talking of electric powertrains becoming prominent about 8 years ago. Well, just before that, we had put together a solution for fluids and electromagnetics and structural aspects working together with the best-in-class tools in that area. And that was a step that we had taken in anticipation of the electric powertrain. And with the electric powertrains becoming prominent, we were immediately able to go into that market and establish ourselves as one of the dominant suppliers in that market space. So what we are looking forward now is autonomous driving. This is completely going to change the automotive industry. It is also going to change how the focus of simulation. If you think of autonomous driving, it's like one giant control loop, and that control loop requires an immense amount of simulation, drive scenario simulation or sensor fusion simulation, or how the sensors sense the world, the physics of the sensors, and control software, and making sure all of that entire loop can be executed well. So it's opening up an enormous field for simulation that Ansys is again positioning itself through our tools and partnerships and new developments.